Okay, in this video, we're going to discuss the cosine function. So I have my unit circle here as a reference. We're going to graph it on the axis that I have here, and you can see that the x-axis is in radians, so we're going to make sure we use the radians as we go around. Here we have 0. The cosine is the adjacent side, which is the x-axis. When we drew our triangle in here, this would be the adjacent side. So we're going to take the x value. So at 0, we're going to be up here at 1. That's already a difference between the sine and cosine. We're going to do the same thing as we move around. So we talked about key points. We're going to go with pi over 2 because we know that that will help us out with a key point. And I can see that the cosine, the x value is 0. So at pi over 2, we're going to be at 0. We're going to go to another key point here with pi going out to the x. I can see that the x value is -1. So we're going to go down to -1. And 3 pi over 2 will be another key point. And we'll grab the cosine there, which is 0. And full circle, we're back to where we started with 2 pi. So back at +1. So here is our cosine function. You still get that same periodic shape, but instead of starting at 0, 0 like sine did, we're going to start at 0, 1. And I could do the same thing on the left. If I go to negative pi over 2, I'm traveling this way. I'm back at 0. If I went to negative pi, I'd be at -1. I could do the same thing. -3 pi over 2 would bring me up to the top. Cosine is 0, and then a full circle, we're back at 1. So there's your negative side. So there's our cosine function. Okay, this should be the first example in your notes on the cosine side. So we have our function a cosine b times x minus c plus d. And we have already talked about this with the sine function. The a out here in the front is going to cause a vertical stretch or compression. Specifically for this function, that means it's going to change the amplitude. So our amplitude is going to be 0.5. Made it a little bit shorter. This value out here is going to be causing a vertical shift. So we are affecting the midline. So our midline is at +2, and we can use those two numbers to sketch our boundaries. So at +2, there's our midline in the middle. From +2, we're going to go up 0.5, so that's going to give us 2.5. And from +2, we're going to go down 0.5, so that'll be at 1.5. So your amplitude is this distance here between the midline and the minimum, or the midline and the maximum, and the midline is that horizontal line that runs through the middle. Okay, if we go back to the function, you can see that the b value is 1, so there's no change in the period. It's going to stay 2 pi, which means we're going to get one full trip around the circle in 2 pi. That's going to help us. And then there is also no phase shift because there's no c. Now we're going to use what we know about the unit circle, use what we know about the parent function, and we can sketch this. So the cosine again started at 1, which means it's starting at the maximum. So we're going to start at the maximum. And then we went over here and it got to 0. Well, 0 is like the midline. So we're going to go down to the midline at pi over 2. When we were at pi, we were at -1, which is the minimum. So at pi, we're going to have a minimum. And this is how you're using those boundary lines to guide you. We're back at the midline for 3 pi over 2. And then we've made a full circle when we got to that 2 pi, so we're back at a maximum. So there's your cosine function. We could go backwards and do the same thing. So at -pi over 2, we're down at the midline. -pi, we have a minimum. Negative 3 pi over 2, we have our midline, and then negative 2 pi, we have that maximum. So there's your cosine function with a vertical compression of 0.5, which made it shorter, and then a vertical shift up 2. Okay, here we go with example 2. We have an amplitude out here that's invisible 1. We have a midline that's also 1. So I'm going to set up our boundary lines. So I put our midline at 1, I went up 1 unit, so we have maximums at 2, and down 1 unit, so we'll have minimums at 0. We do have a b value of 4, so we'll use that to find our period. Our formula is to take 2 pi and divide by the b value. If I reduce the fraction 2 over 4, I get 1/2. So pi over 2 is our period. And the last thing is that we don't have anything added to x, so there is no phase shift. Okay, let's talk about the period. So the period is pi over 2. We know that the cosine is going to start at 1, which is our maximum. In pi over 2, it needs to complete 1 trip around the circle, 1 cycle. So at pi over 2, it's going to have to be in that same position. So if we think about the shape of it, halfway between those two maximums, there's going to have to be a minimum. And halfway between a maximum and a minimum, it's going to have to hit that midline. There's your 1 period. I'm going to draw a couple more. There's the cosine function for 4x, where b is 4. Again, you take 2 pi divided by the number. So since the number is larger than 1, it's going to cause a horizontal compression. It's going to make the period smaller. Okay, for our last example, we have the amplitude of 1. This time we have a midline at negative 1. There is no b because it's an invisible 1 there, so no change to the period. And we do have a phase shift because we have something added or subtracted from x. So our parent function has x minus c, so that is x minus a negative pi over 2 sitting there. So this is going to move it to the left. So I'm going to set up those boundary lines. Okay, so there's our boundary lines. I put the midline at negative 1. From there I went up 1 because that's the amplitude. That left me at 0. And then down 1 left me at negative 2. Okay, we're going to deal with the phase shift. So cosine started at 1, which means it normally would have been here. But that phase shift is pushing it to the left pi over 2. So I'm actually going to move that point pi over 2 to the left. And I'll show you another one. So the value for pi over 2 should have been 0, which means it's at the midline. So normally it would have been there. But this is going to move it over pi over 2. So it's going to actually land here at a y value of negative 1. And after you do a couple of those, you can see that shape start to appear. So pi should be at negative 1, which means it's a minimum. And we'll move it back pi over 2. And we'll do one more. 3 pi over 2 should be at 0, which is a midline. And we'll move it back pi over 2. So I'm going to connect these blue lines, and there is your cosine.